First of all, in older houses, we see electrical fires. There's a complete increase in fires in the older houses. If we look at fire statistics, what does it say? We're looking at about 186 fires a year. There's about 1.6 million homes, so whatever percentage that is, it's a substantial number of fires over a 5-year period, representing about 10% of residential fires. Interesting, in 40% of the fires that are reported, the cause of the fire is completely unknown. Only a fraction of them, being 10%, are confirmed electrical, but yet 40%, people have no idea what caused the fire. Us as electrical professionals, from what we see, is man, oh man, we see so many dangerous fire hazards in these older buildings that are inexpensive to fix. And I would be quite surprised to see that a big chunk of that was not electrical. So we think that their electrical fires are actually much more prevalent than they are reported to be. And even the ones that are reported makes up, 10%. We took the number of fires and we plotted them, taking all the numbers from the BC fire statistics, and plotted them versus age of a house, and then divided them by the number of houses that are existing today of that decade. So we can find a relationship between age of house and fire. And we do see a definite peak, which is very interesting, in the houses between 1950, 1965, 1970. Interesting, that's the period of ungrounded circuits, post-knob and tube, and also aluminum wire. So that's where we see the predominant electrical fires. There's 25% of the houses, the date of construction was not recorded. So there could be some error in this graph. I would say that line would bring up at the earlier houses, in the 1930, 1940. It would also have fires, but we don't have data on that. What's causing electrical fires? From what we see, original wiring, yes, it can be faulty. Knob and tube, aluminum wire, 60 amp services. Yes, they can be faulty. Yes, they can cause fires. But without question, handyman tinkering is the cause of 99% of fires. Badly installed modern wire in the wrong places, the wrong type, without grounding, incorrect circuit breakers, incorrect bonding, you name it, it's the add-ons that are done dangerously. Let's go quickly and look at the different components of the electrical system of a house. First of all, there's 3 components to the electrical system. There's what's called the service and panel board, there's the wiring, and then there's the electrical devices. The service is the power coming in. In the worlds of the water, that would be like I got a 1-inch pipe coming in from the street going to a big shutoff valve. Then you got the wiring. That's like the copper tubing going throughout your house to the sinks. And then you got the devices, which is like the taps that you turn on and off. The service upgrade is like changing from a 3/4-inch water system to a 1-inch water system, changing from a 60 amp service to a 100 amp service. Is your house 100 amp or 60? About 50% of the boxes will be pull switches. The other 50% will have a switch, a circuit breaker switch. But in the 50% with boxes, on every box it says rated for 100 amps. So people are saying I got 100 amp service. Well, it's 60 amp in 99% of those boxes, if you open it up. The 100 amps is referring to the rating of the enclosure. So please open up the box and see what the fuses are. That's what determines the service size. 60 amp service was the norm in house wiring until the 70s. And then in the 1970s, because of the potential of basement suites and the potential of more heating demand, which was electric ranges, electric dryers, and baseboard heaters, for the potential of those extra things that were going to be needed due to multiple suites, the Canadian Electrical Code said for all new houses greater than 80 square meters of living area, we're going to have a minimum of 100 amp service. It's not because the 60 amp was safe, it was because the potential of putting in a future upgrading, you needed extra power, and at the time of installation, it was only 5% more in the cost of your installation to put in a 100 amp versus a 60 amp. It doesn't mean the 60 amp is not safe. It means that it needs to be visited case by case. Even looking at the service switch itself, 150% is the pull switches, the other 50% is a main circuit breaker. People will often see that main circuit breaker and say, oh, I've got 100 amp and I've got 200 amp. But actually all they've done was change the circuit breaker or the panel itself with the original 60 amp wires coming into the house. What they did have in this house was no longer a safe 60 amp service. Now they've got a dangerous 60 amp service. So you really need to have an electrical inspector, a master electrician, make comments on service size. The common hazard we see in most of the older panels and that didn't have enough space is overloaded circuit breakers. Circuit breakers were designed for 15 amp branch circuits for running your lights and your receptacles. If you start running a basement suite off existing breakers, the breakers are going to trip. So people who don't really know what they're doing will fix it by changing the breaker for a 30 amp. Well, what they've really effectively done is just take away the circuit breaker protection that your circuit needed. And that's what happens. The result of oversized circuit breakers combined with excessive electrical demand. Knob and tube. Wiring before 1950. This was the standard in all houses. If we see a house like this and it's got the old two-prong receptacles, we test the wire behind the walls. In 99% of it, the old wiring is tickety-boo, and the outlet itself is fine for what it is, which basically you can plug in something with two prongs, which is a light. And that's what it was designed for. Where people have erred is what they've done is they've taken the two-prong and changed it over for a modern three-prong. Now you can plug in your computer, your power bar, your TV, your entertainment system. But in every one of those cases, the ground is not hooked up. It's just going behind the wall. It's not working. You've got no ground protection. So you've taken a system that was designed for lights and stuff that did not need ground protection, and you've made it into an unsafe system. Hence the peril of knob and tube. What is the solution? Rewire for $20,000 or change the outlet itself. That simple outlet back there, that modern outlet, can be changed for a GFCI outlet. GFCI does not need a ground wire to function. It does, however, provide with three prongs out so that you've got your ground protection, which is fabulous. A GFI actually provides better ground protection than a ground wire because it will trip at 6 milliamps instead of 15 amps, which is what a breaker trips at. Anyway, it's a very, very safe system. So we're going around to these old houses seeing knob and tube with outlets all being three-prong. Dangerous, dangerous, dangerous. What's the solution? $20 an outlet. Change those outlets. Now they are safe. In 99% of homes, we're finding knob and tube present today in the older houses built before 1950. It's usually not visible due to a finished basement. The knob and tube is in excellent condition in 99% of the houses. But in 99% of the houses, the original two-prong outlets are now three-prong. Hence, the houses are rated high risk by PowerCheck. What's the fix? Hire an electrician to go through the house and change those outlets for GFCIs at a cost of less than $500 a house. Wiring of the 1950s, ungrounded outlets continued through the 1950s. They took the two wires of knob and tube and wrapped them together with a case. It had no ground. They were wired to two-prong receptacles, which have now been changed over to three-prong in most of the cases. Again, in those houses, the solution is GFIs. 1960s, 1962, Canadian Electrical Code said all outlets must be grounded from now on, and that was due to the advent of electrical appliances, which needed ground. Washing machines, kitchen counter appliances. Wiring of the 1960s, now we're bringing in ground wires. Then in the 70s, we've got modern wire, modern plastic wire, but the giant problem that happens in modern houses is the abundant rise in basement suites, hence the abundant rise in unauthorized electrical work. And that's what we see. There's also 1966 to 1974, the aluminum years. It was a system designed for inexpensive electrical systems in your house due to the price of copper, which went very high during the years of the Vietnam War. It was installed in the vast majority of homes. Had the system been not touched and been original, it'll be safe today. For one simple reason, the outlets were designed to be compatible with aluminum. Modern outlets are not rated for aluminum, they're rated for copper wire. It's the connection between the aluminum and the copper screws that causes the problems. Had they left it original, it would have been fine, but they didn't. They changed them for modern outlets. Again, the solution is pigtailing. The thing about pigtailing is it has to be done with approved wire connectors. Approved wire connectors, if you use the wrong ones, you've just shifted the point of fire from the receptacle to the wire connector. But approved pigtailing is an excellent solution. Again, it's about $1,000 a house, maybe $1,500 if it's a bigger house, to pigtail a whole house with aluminum. Then you got a house that you don't have to worry about. Anyway, let's run through some fire hazards really quick. This is the kind of stuff we see: undersized cables, incorrect cables, ungrounded cables, oversized circuit breakers, bad electrical connections. We call them mouse holes. They're actually called knockouts, those holes, but mice go into those holes and build nests, and then you have fire. It takes 25 cents to buy a little cap that snaps on and seals it up, and then you don't have problems. So many houses burnt to the ground because of mice and spiders and stuff going into the electrical boxes because of mouse holes. It can be fixed so easily. What do we got here? Handyman add-ons. No junction box behind lights. Staples. People say, what's wrong with the staple? It makes it look nice. Well, a staple, what's a staple made out of? Metal. It's all fine, but a staple's putting pressure on the insulation. It's putting pressure on the wire. And then one day that insulation gets cracked and there's a little tiny crack in there. And then the staple is now making direct contact between the hot and the neutral. Boom. Fire. That's much more dangerous than had they just left it alone and just had the extension cord lying on the ground. One of the classic things we see is people with Christmas lights. You're supposed to use plastic clips to hold the lights up. We see about 10% of houses, people go by with staple guns, boom, 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 put up their Christmas lights. It's a recipe for fire. What does it cost to get rid of? Nothing. That's the kind of stuff that causes real fires. Baseboard heaters incorrectly installed. A new problem we're seeing all the time now is PEX pipe repairs. People fixing a little bit of the copper system with plastic pipe. Well, what that does is it chops your grounding, because copper water pipe system is part of the grounding system in these older houses. Summary: electrical fire hazards in most houses built before 1975 are found. Though deterioration of older wiring is occasionally found, the vast majority of fire hazards are due to handyman tinkering. An electrical examination is what's needed. Again, I've already told you about PowerCheck. We're a group of master electricians from here to Toronto doing safety examinations, making sure a house is safe. I think the thing that really has led to the rise in the findings has been impartiality. There's no ulterior motive for anything except an accurate inspection. And the result has been safe houses, happy homeowners. If you have any more questions, please go to our website, powercheck.ca. Many thanks.